This video covers 4 questions from the midterm review document. The first one was problem 13. First we're going to plot the point 1, 2 over 1 up 2. And then we're going to plot the intercepts. If x is equal to 0, y is equal to minus 9. And if y is equal to 0, x is equal to 3. So connect those points with a line. This is the line L. That's L, and this is the point P right next to it over here. And so the perpendicular line to L that goes through P would be at a right angle to L. So about like, there's a right angle to L. So about like something like this. Through P, perpendicular to L. There's your right angle. All right, so this is the line that we're supposed to find the equation for. This second line. So we know 2 things about it. We know that it goes through the point 1, 2, and we need a slope. To find the slope, we find the slope of the original line L. So the slope of L is going to, probably the easiest way to find it is just use minus a over b. So it's minus 3 over minus 1. Gives us a slope of 3. And so therefore the perpendicular line, if a line has a slope of 3, all lines perpendicular to it have a slope that's the opposite reciprocal. So first we flip the fraction, changing the roles of x and y. That's one of the things that happens. It goes from 3 to 1/3, and then we change the sign. You can tell that the perpendicular line is a negative slope. As we move east along this road, we're going south. So that's negative 1/3. So now we have a point and a slope. So the equation of that line, that second line, the perpendicular line, is just using point slope formula. Y minus 2 equals the slope minus 1/3 times x minus 1. And you could change this to a different form if you like, or you can just stop right here because it says find equation in any form. There it is. There it is in point slope form. You could, yeah, that's enough. All right, here, there are 2 similar triangles. There's this little triangle here with one side equal to 1.5. And there's this side equal to 6. And then there's a much bigger triangle that has this side equal to 10 and this side equal to h. H is the number we seek. And if you look at this carefully, this angle is the same as that angle because it's the same angle right here. It's in both triangles, and this is a right angle for both triangles. So this angle up here must be the complement of the other acute angle. So all 3 angles are the same. So these triangles are similar. They have the same proportions, so any ratios of analogous sides will be equal. So if we take the ratio of the long leg to the short leg of the little right triangle, that should be equal to the ratio of the long leg to the short leg of the big right triangle. Then we cross multiply. 6 times 10 is 60 equals 1/2 h. So h is equal to 60 divided by 1.5, which I can write as 3/2. To divide by a fraction, you just multiply it by its reciprocal, so that h is equal to 60 times the reciprocal, which is 2/3, and 2/3 of 60 is just 40. So the height is 40 feet. And moving on to number 28. All right, so the function problems, the key is to isolate your inputs and your outputs. So let's think about what the input is here. The input says when a certain target store prices a tub at $3, it sells 100 a day. If it prices at $2, it sells 150 tubs a day. So a linear relationship between price and tubs sold, and we're supposed to find a function that returns tubs. So tubs is the output. So the output is tubs. So we want to know how many tubs we sell for a given price, for a given value of price P. So we call the function T of P. The function T returns the number of tubs sold for a given price. And we're told it's linear, so we know T of P is equal to mx plus b, which in this context is mp plus b, since p is the input variable. And now we just have to come up with a table to take care of these inputs and outputs. See what we got here for the P, and then we have T of P. We're told that $3 is the price that sells us, that leads to the sales of 100. $2 sells us 150. So when the input goes down 1, the output goes up 50. So reducing the price by $1 leads to the sale of 50 more tubs. So that's a slope of 50 over minus 1, which is minus 50. So this number right here is minus 50. Now I just have to find B. I can plug in either one of these 2 points. I'll put in the second one. So 150 is the value of the output when the input is 2. If I solve that, I get B is equal to 150 plus 100, which is 250. So I go back up here now and replace that with 250, and I now have the function T of P. So it's $250 tubs minus 50 tubs for every $1 increase in sales. All right, so if you want to sell 140, that's the output. That's the T of P column. You're saying, what's the input? What's the price that leads to sales of 140? So to do that, we set the output to 140 equals minus 50p plus 250. When you're given the output instead of the input, you have to solve an equation. You can't just plug it in. We subtract 250 from both sides. That's minus 110 equals minus 50p. Divide both sides by minus 50. You get minus 110 over minus 50 is equal to the price. That gives you 140 tubs. That is, if you get rid of the zeros, divide top and bottom by 10, and then take advantage of a negative over a negative, that's 11/5. And 11/5 is 2 1/5, which is $2 and a fifth of a dollar. And a fifth of a dollar is 20 cents. That's 220. 220, a price of 220 according to this model would result in the sales of 140 tubs a day. The next question asks for a reasonable range and domain, which is subject to, it's a subjective question. You could pick a lot of reasonable things. I think the place to start is obviously a price less than $0 wouldn't make any sense. In fact, a price of $0 wouldn't make any sense. And you could argue that a price less than 50 or 25 cents might be crazy. But so any lower limit you want to pick that's reasonable, I'm just going to pick 0, and I'll put strictly greater than, because a price of 0 doesn't make a lot of sense. If you charge $5, minus 50 times 5 is 250. That leads to sales of 0 tubs. So there's no point in, by the time you get to $5, you're already selling nothing according to this model. So prices between 0 and $5 are reasonable. That's your domain. And again, that's up to you. Whatever you pick for your domain, though, as long as it's within reason, whatever you pick has to have a matching range. That part isn't up to you. So the smallest, the largest possible sales of tubs would occur when you priced them at the lowest possible value. If you price them at $0, according to this model, plug in 0 here, you get the y-intercept, or B, you get 250. The output when the input is 0, the number of tubs sold when the dollar value is 0. So your output, T of P, would be 250 tubs at a price of 0. If you charge $5, we said before, your output is 0. So it's inverse relationship. So you get the largest number of tubs when you set the price the lowest, and vice versa. So that would be a reasonable domain and range pair. Lastly, for the function here, to find the period, or to find if it is period, you ask yourself, can you hack it up into horizontal sections that just repeat over and over again that have the same length? And if you look at this section right here, that up and down motion, that's the same over and over and over again. It just repeats. So it is periodic, and the length of that section, this distance right here, probably easier to go peak to peak because of the way the graph is marked. This peak right here to this peak right here is one complete revolution. Notice when you get to the next peak, you're at the top going down in both cases. So that's a complete revolution. That takes you on the x-axis from minus pi to 0. That's a length of pi. So yes, it's periodic, and the period is pi. Odd, even, or neither, we look for, we take a positive x and a negative x, and we ask, are the outputs always going to be the same for any such pair, or opposite, or neither? So let's go to pi over 5, so we'll go 1/5 pi short in either direction to see what we get for, if that's x, that's opposite x. We plug in opposites. What happens to the opposite inputs? What happens to the outputs? Are they the same, or are they the opposite, or are they neither? Your output is around here somewhere, and the output here is the same number. This number right here, f of x and f of minus x, are the same. That's the signature of an even function. If you look at that, it's always going to be that way. If you look at all the points, it'll be that way for any pair of x and minus x, or for any value x. And that's, so it's even because f of x equals f of minus x. Or you can say that it's symmetric with respect to the y-axis. In other words, if you were to fold the graph along this line, the y-axis, you would fall right on top of itself.